We have this worksheet. It is two-sided. Today we're going to do the front side. Tomorrow we're going to do the back side. All right. On this video I'm going to explain the even ones, and you guys should be able to do the odd ones the second half of class. If you need help on the odd ones, you could look at the other videos that I've posted. So let's do the even ones on this guy. So let's jump to number 2. And you need to be able to graph and also state all the additional information that you can about a parabola. We begin, step 1 on graphing is to find the vertex, which is a coordinate. And that vertex, you find it using the formula x equals negative b over 2 times a, which is really negative parenthesis over 2 times parenthesis. And you look at your a, b, and c from your standard form quadratic trinomial equation. The a value is negative 1, the b value is negative 2, the c value is 1, which we don't even care about because c is not on the formula. So the b value is negative 2, and the a value is negative 1. So you do have a minus minus, which changes to plus plus. So what we really have is x equaling positive 2 over negative 2, which really means that x is negative 1. Is everybody with me? Good. The vertex x value is negative 1. We still need the y value, so we need to plug that negative 1 into the original function, into the x positions. So I'm going to take that function y equals negative x squared minus 2x plus 1, and I rewrite it with parentheses. That way I could safely plug in the negative 1 right in both of those parentheses. Now, let me tell you this. This is where I see so many students mess up. Let me zoom in so you can see this. So many students, when they simplify this, they think, oh, minus minus changes to plus plus. That's incorrect, right? Where does that rule come from, that a negative and a negative change to a positive? Multiplication, right? Negative times a negative is a positive. So you can't multiply before exponents. You have to do exponents first before multiplication. So you have to use PEMDAS, right? Exponents first. So please do the negative 1 squared, which gives you what? Positive 1. And then what about that negative sign in front? You could just bring it down. So that's really a negative 1, not a positive 1, okay? And then when we go negative 2 times negative 1, that's positive 2. And then you bring down the plus 1 at the very end. And it's just a question of adding and subtracting here. Negative 1 plus 2 is 1, and 1 plus 1 is 2. So the y value is really 2. Let me zoom out. So the vertex y value is 2. So negative 1, 2 is the vertex. Let's go to that most important point, the negative 1 and the 2. So negative 1 on the x, 2 on the y. There it is. Step 2 on graphing. On the board it says to draw your axis of symmetry right through that most important point that we call the vertex. So it's easy to draw it, but in addition to that, you're going to have to state what the axis of symmetry equation is. And let me tell you guys, any vertical line is no longer a y equals mx plus b line, right? It's not a y equals, it's actually x equals. Any vertical line is going to be x equals whatever that x value is, okay? And let me repeat that a different way. It's going to be x equals whatever the x value of your vertex is, right? So what's that equation? X equals what? Negative 1, right? It can't be positive. Here's positive 1. That line's not through positive 1. It's through negative 1, right? If the line would have been over here, then it would have been x equals 3. If the line was over here, it would have been x equals negative 4. It all depends where your line's at. It's right here, crossing the x-axis right at negative 1. It's really just the x value of your vertex, negative 1. So to state the axis of symmetry equation, you have to write x equals negative 1. Now, I'm saying all this because we have this extra paper that says additional information. So far we've found that the vertex is negative 1, 2. So let's go to that paper and let's put negative 1, 2. And we said that the axis of symmetry is the equation x equals whatever that x value is, the x value of your vertex, negative 1. So we're going to fill in all this additional details once we're done graphing it. So let's keep graphing. We already did the vertex. We need more points. How could I get more coordinates?
The y, 2,
x, y table or the 1, 1, 2, 4, 3, 9 pattern. It's whatever you guys want. I'll do both just because this is the first question that we're doing. What 2 values would be good to plug in for my inputs? What 2 numbers would be good to plug into my inputs? 0 and 1. Those are great values. Why? Because 0 and 1 are both on the right side of this axis of symmetry. And that's great because when you plug in 0, you're probably going to get a coordinate somewhere here. When you plug in 1, you're going to get a coordinate somewhere down here. Then you're going to be able to map over the coordinates to get your full parabola. So let's plug in 0. And I don't recommend doing this in your head, but actually 0, yes, 0 is always easy. When you plug in 0 for x on both of those, everything becomes 0 except your c value. So whenever you plug in a 0 in a standard form quadratic, your output's always going to be the c value, which happens to be 1. And if we graph the coordinate 0, 1, we end up right here at that blue dot. Now let's plug in the value of 1, and I am going to do this in my head. What is 1 squared? Help me out here. What's 1 squared? 1. And with a negative in front, that's going to make it a negative 1. And then over here, 2 times 1 is 2, but with the negative in front, it's a negative 2. So you have a negative 1 and a negative 2. That gives me a negative 3. And negative 3 plus 1 is negative 2. Are you with me? Okay. So let's graph the coordinate 1, negative 2, and there it is. Let's map those coordinates over to the other side, right here and over here. Again, how do I map? It's simply 1 unit away from the axis of symmetry, so I go 1 unit and I get my dot. This is 2 units away, so I go 2 units and I get my dot. Now we need to connect the parabola, draw it, draw some arrows on it, and we have graphed it completely, and that's great. That's awesome. But we still need to answer all the additional information, all right? So, oh yeah, by the way, if you recognize that the a value is negative 1, remember the a value tells you how wide or how narrow the parabola is, and any parabola with the a value of 1 or negative 1 is going to be exactly as wide as our first graph that we ever did, which was y equals x squared, which had the pattern 1, 1, 2, 4, 3, 9, which means you could have used the pattern 1, 1, 2, 4, 3, 9. Let me write that down here in case you forgot. 1, 1, 2, 4, 3, 9, in case you forgot. So from the vertex, if you go 1 over and 1 down, you'll get to that blue dot. From the vertex, if you go 2 over and 4 down, you'll get to that blue dot. From the vertex, if you go 1, 2, 3 over and 9 down, 1, 2, 7, 8, 9, you'd be down here. But you could put the dot there, and that's exactly where the parabola goes through. And you just map over those points to the other side, and you could have graphed it that way a lot faster with the pattern 1, 1, 2, 4, 3, 9. Let me repeat, the only time you could use the pattern 1, 1, 2, 4, 3, 9 is if your a value is positive 1 or negative 1. Okay? If it's 2, you have to modify the pattern or just use an XY table. XY tables always work. Anyway, let's answer whatever else we can about number 2 here. The domain, what's the domain of that parabola? X equals all real numbers. The domain of any parabola is x equals all real numbers. It doesn't matter if it's wide, narrow, opening up, or opening down. It's always x equals all real numbers. Now the range value is y, and it's either going to be greater than or equal to or less than or equal to the y value of your vertex, right? So what do you think? Does this parabola open up or does it open down? Down. It opens down, right? Like you're here at this level and then it goes down. So your y values have to be less than or equal to that y value of your vertex. So y has to be less than or equal to, what's the y value of your vertex? It's 2. So there's your range. Y is less than or equal to 2. Another one that we've been doing is the y-intercept. Now the y-intercept, you could give it to me as a coordinate, or you could just say the y-intercept is what? The y-intercept is, you guys, where does a parabola cross the y-axis? Right here at 1. So you could just say the y-intercept is 1, or you could actually give it to me as a coordinate 0, 1. And you don't even need it. You don't even need to look at the parabola. You could look at your original quadratic trinomial equation and say, well, to find my y-intercept, I need to set my x's equal to 0, which will always be my c value as my answer. So you could set x equal to 0 and get out 1 as an answer. All right. So this is something new. 2f, the final thing I ask of you, x-intercepts. All right. Now, I want you to do an approximation, right? Later on, we'll be able to be precise. Next week, we're going to actually find the exact locations of where this parabola crosses the x-axis. I'm talking exact, next week. But right now, I just want you to give me an approximation. Where do you think the parabola crosses the x-axis? Negative 2.5. So you have to say negative 2.5 and what? and 0.5 or positive 1/2, whatever you want. So yeah, you could use decimals, you could use fractions, but let's do this, guys. Since we're approximating, let's put the little squiggly line, right? The x-intercept is at negative 2.5 or negative 2.5, and what do we say, 0.5 or positive half, whatever you want. You don't even need the and. You could just put comma, whatever. But it's not a coordinate, right? It's where it crosses your x-axis. And that's why it's important to put the squiggly equal sign, not an equal sign, because they're an approximation. And that's the only new thing that we're adding on today. Do we all understand number 2? Great. We're just going to repeat that process over and over and over. Let's take a look at number 4 here. Number 4. Let's find the vertex, which is a coordinate. And I find that by doing x equals negative b over 2 times a. And the b value happens to be negative 6. The a value happens to be negative 1. The c value I don't care about. It's not in the formula. The b value is negative 6. Plug that in. The a value is negative 1. Plug that in. A negative 6 becomes positive 6. We end up with positive 6 divided by negative 2, which is negative 3. 6 divided by negative 2 is negative 3. And that is our x value of our vertex. To find the y value, we must plug it in. I want to rewrite it right below it so it'll be crystal clear for you guys. Instead of x's, I put parentheses, and I am plugging in a negative 3. And when I do this math, I recommend you using a calculator and typing it in exactly the way it is, or showing all the details of your work. Like right here, don't change the minus to plus. Again, that's most common mistake students make. You have to do the exponents first, right? So negative 3 squared, that's 9, but with the negative sign in front, it becomes a negative 9. And then you go negative 6 times negative 3, that's positive 18. Then we have minus 8 at the very end. So negative 9 plus 18 is 9, and 9 take away 8 is 1, and that is the vertex y value. So the vertex is negative 3, 1. Of course, you could have done all that math on a calculator and be more comfortable with your answer. But anyways, the vertex is negative 3, positive 1. Go to negative 3, positive 1. Put a dot right there. And now, from that dot, you could use the pattern 1, 1, 2, 4, 3, 9. But before that, let's draw the axis of symmetry, which is a vertical line going right through that vertex value. And what is the equation of that axis of symmetry? What is the equation of that axis of symmetry? Remember, any vertical line is not y equals, it's x equals. So what do we say the equation is? X equals what? Negative 3. I mean, it's definitely not positive 3. The green line's over here at negative 3. Guys, this is like a free point right here. The axis of symmetry equation will always be x equals the x value of your vertex. The x value of your vertex is negative 3. Okay, let's get more coordinates. You could use an XY table if you want, or you could use a pattern. What do you guys want to do? Pattern, okay. So if I plug in, or 1 over, 1 down, that would be a coordinate. Let's put that coordinate right there. If I go back to the vertex and go 2 over, 4 down, 1, 2, 3, 4, I'll be right there. And of course, you could map them over to the other side. Now, if I were to have plugged in a negative 2 for x, I would get out a 0 for y. How do I know that? Because this is my coordinate, negative 2, 0. So if I plug in a negative 2 for x, I'd get out a 0 for y. What's this coordinate? It's negative 1, negative 3. So if I did plug in a negative 1, I'd get out a negative 3. Just to let you know, the pattern really does give you the coordinates, right? Map them over to the other side, and you'll have your perfect regular U-shaped curve opening down, though. And then we answer all the extra details about question number 4. All right, so the vertex on question 4 is negative 3, positive 1. The axis of symmetry, that vertical line, is what? X equals negative 3. The domain always on any parabola is x equals all real numbers. The range is always y, and it's either going to be greater than or equal to or less than or equal to the y value of your vertex. So what do you see? What do you say? Is this greater than or equal to or less than or equal to? Less than or equal to. Why? Because it's opening down. The a value is negative, which means it's less than or equal to. All right, so it's less than or equal to what? 1. That's right, the y value of your vertex. Y-intercept, where does this cross the y-axis? Well, I can't see it. I don't know. So let's do it algebraically. Where does it cross the y-axis? -8. So you could just put -8. And by the way, how did you figure that out? To find the y-intercept, you set x equal to 0 and solve, right? So right here, your x is, plug 0 in there, your c value is going to be your answer. So your y-intercept is -8. If you extended this, it would cross way down here at -8. Make sense? How about your x-intercepts? -2 and -4. Perfect. It crosses the x-axis here and here, both of those. So we're going to say -2, comma, -4, or -2 and -4. It's not a coordinate. Don't put parentheses around it. Maybe you want to put the word and so you don't confuse it with the coordinate. -2 and -4. So that's everything we could say about number 4. I hope we're good. Let's move on. Jump to number 6. Number 6, again, we're going to begin with the vertex. I'm getting lazy. I'm just abbreviating here, putting a V and then the coordinate. Formula x equals -b over 2 times a. The a value is 2, the b value is -4, the c value we don't really care about right now. So -4 is right in there, the 2 is right in there. Minus minus changes to plus plus. We end up with a +4 over +4, which is 1. The vertex x value is 1. We need the y value. All we got to do is plug it in. So we have 2x squared minus 4x minus 1, and I am plugging in a 1 right there. Doing the math, 1 squared is 1, 2 times 1 is 2, 4 times 1 is 4. Let's not forget about the minus sign that comes down. There's also a -1. 2 minus 4 is -2. -2 minus 1 is -3. So 1 comma -3, that's a y value. That's our vertex. That's the most important point. Let's go to the coordinate 1, -3. Let's put a dot there. Step 2 on graphing is what? Drawing your axis of symmetry. So that dotted line right through the vertex. And we might as well label the equation of that dotted line. What's that vertical line equation? Okay, you can't just say -3. You have to say x equals 1. Right? Why x equals 1? Because this line, this vertical line, crosses the x-axis at 1. Not at -3. Right? It's not over here. It's right here at 1. All right, so that's the axis symmetry equation. We need more coordinates. We could use the pattern if we modify it. Instead of 1, 1, it would be 1, 2. Instead of 2, 4, it'll be 2, 8. But let's not modify. Let's actually just work with the XY table. And let's plug in numbers that are nice and easy, that are on the same side of that axis of symmetry. I'm going to plug in the number 0, because 0 is clearly on the left side. And I might as well plug in the number -1. Or maybe not. Let me just go with 0 right now. When I plug in 0, it's nice and easy because the c value will always be your output. So 0, -1 is a coordinate right there. I could map it over to the other side. So when I map it over to the other side, technically I'm also getting a coordinate 2, -1. So if I were to plug in 2, I will get out a -1, right? But you don't have to, but we just mapped it over. That's fine. So think about, you have 3 coordinates so far. That's 3 inputs. 1 input of 0, there it is. 1 input of 1, we already inputted 1, got out a -3. And 1 input of 2, we never actually inputted it. But if we did input it, we'd get out a -1 because that's a reflection. So I need one more input. Do you guys want to input -1 or do you want to input +3? It's totally up to you. +3, that's fine. I mean, -1's pretty easy, actually. Check it out, -1. Let's do this in our heads. What's -1 squared? 1. What's 2 times 1? 2. What's 4 times -1? Or let's do this. Call it -4 times -1. That's +4, right? So we have +4 and +2. That's 6. And 6 minus 1, that is 5. So when I plug in a -1, I get out a +5. Let's do that. -1, +5, it's way up here, right on the edge. Map it over to the other side. I should do that in green. Sorry, stay consistent. And here is my Slightly narrower parabola. It's not as wide as our regular parabola. That's because the a value is further away from 0. The more the a value is further away from 0, the narrower it gets. The closer to 0, the wider it gets. Let's all go to stating everything we possibly can about this parabola. So the vertex is 1, -3. Axis of symmetry is the equation x equals 1. You have to say x equals or else it won't be a line, a vertical line. The domain is x equals all real numbers. The range is y is what? Greater than or equal to or less than or equal to? Greater than or equal to what? The y value of your vertex. -3. Right? I mean, that's visually you could see here's the y level -3 and your parabola is there and it's also above. So that's why it's greater than or equal to -3. How about the y-intercept? Where does it cross the y-axis? At -1. So you could just write -1, or if you want, you could also do the coordinate 0, -1, which technically means that you set x equal to 0 to find y, and setting x equal to 0 will produce your c value as your output, your y value. Now for your x-intercept values, where would you say an approximation, so let's put the squiggly equal sign, where would it cross the x-axis? 0.3 is right here.
Wait, what are we trying to say?
-0.3 would be good, right? So let's do -0.3 and 1, 2, 2.1, 2.2. Sure, it's an approximation, so it doesn't really matter. 2.2. Now, like I said, next week we will learn exactly, we'll find exactly the location, precise decimal location or radical value of wherever it actually crosses the x-axis. But right now, just give me what you believe. Ballpark, -0.3 and 2.2. Last one. I said, dang, it's a long video. Number 8. Vertex. X equals -b over 2 times a, negative parenthesis over 2 times parenthesis. B value is 4, a value is -2, c value is 3. We don't care about 3. So we have a 4 for b. Our a value is -2. Let's do this math. Up on top, you get a -4. On the bottom, you also get a -4, which means that your vertex x value is +1. We're going to plug in 1 to find the y value. You know what? For the sake of time, let's just do it in our head here. What's 1 squared? 1. What's -2 times 1? -2. What's 4 times 1? 4. What's -2 plus 4? -2 plus 4? 2. 2 plus 3? 5. So when you plug in a 1, you get out a 5. So our vertex is +1, 5. +1, 5 is way up here. We draw our axis of symmetry right through that coordinate, +1, 5. And the equation of that axis of symmetry is x equals 1. Thank you very much, guys. All right, let's now move on to more coordinates. X, Y table. What's the easiest number to plug in? 0. And that'll actually give you your y-intercept value. When you plug in 0, you get out your c value, which happens to be 3. So 0, 3 is right there. Map it over to the other side. Let me change colors here. You get that coordinate. So we need to plug in another value. Like let's plug in -1, and we should be able to map that over and we'll be good. So again, do it on a calculator. I want to do it right here in my head because you guys could catch my mistake if I make one. -1 squared is what? 1. What's -2 times 1? -2. -2 plus, what's 4 times -1? -4. So I have -2 plus -4. -6 plus 3? -3. So when I plug in a -1, I get out a -3. And that's that coordinate right there. I map it over to the other side, which is over there. And there is my perfect graph. Yes, it's a little narrower than usual. That's because the a value is further away from 0. Let's look at our extra details. The vertex is 1, 5. Axis of symmetry, x equals 1. The domain, x equals all real numbers. The range, y is what? Less than or equal to what? 5, the y value of your vertex, right? I mean, that makes total sense. Look, how high is this parabola? It's at the y level of 5, and it's below that. It's at 5 and below, so that's why y is less than or equal to 5. How about the y-intercept? Where does it cross the y-axis? 3? Or you could say the coordinate 0, 3. How about the x-intercepts? Where does it cross the x-intercepts? And we're going to do the approximation symbol. 2.75 for the positives. That's good. That's a good approximation. Very precise. How about the negative one? This is the 2.75 one. It's almost a 3. You could have said 2.8. That's fine. Whatever. How about this guy? Where does that one cross? 0.5 is right here.
Negative 0.83.
Negative. I would go.
Negative 0.3.
Oh, on my paper looks weird.
That'd be negative.
That looks like 50.
It's like 0.56.
Negative 0.56. I'm just going to say negative 0.5. So negative 0.5 and 2.75. Again, these are approximations. Next week, we will be getting the precise x-intercept using square roots. And yeah, we'll be able to get that next week. So we've done half of it. Do the other half. If you need help, watch the other video.